In this video, we are going to continue on the reaction rules of Diels-Alder reaction. So the third rule is the stereochemistry of the dienophile is retained. Okay, if we have cis dienophile, for example, this is cis enophile. When we react these two starting material, what we have is a new compound, and the stereochemistry is retained. If the starting dienophile in cis form, so the end product should be a cis product. Okay, for example number 2 is when we have a trans dienophile. Okay, when we react these two starting material, what we will get is a trans product where we have both enantiomers. The first one is both are trans product, but the COH is at different location. Okay, Diels-Alder reaction can also be used to form bicyclic system. Okay, when we have a bicyclic system, for example, in this case, it is a 4+2 reaction. Okay, we have the diene and then we have the dienophile. Okay, please take a look at this part, this carbon, and then when we react these two starting material at room temperature, what we will get is a bicyclic system. So please take note that the one that I circle here is the same as here. Okay, when it reacts, it will give you a bicyclic system in endo form. Okay, although this is a reversible reaction, however, in order to break the bond of the bicyclic system, we need a very high temperature to give the diene and dienophile again. Okay, what happened is that when we have a diene and we react with a dienophile, what will happen is that this bond, this carbon, will be flapped upward, and then it will give us one carbon bridge. It can either be drawn like this or like this. And the new 6-membered ring is in red. So this is the new 6-membered ring. Okay. A cyclic dienophile can form a bicyclic product. So a bicyclic system is in which two rings they share a common CC bond, which is called fused ring system. And the two hydrogen atom of the ring fusion must be cis, because there were cis in the starting dienophile, and a bicyclic system of this sort is said to be cis fused. Okay, let's take a look at the example. This is the diene and this is the dienophile. If we look at the position of the hydrogen atom here, it is in cis position. Okay, when it is in cis position, when we react those two starting material, we need to know that in the product, the hydrogen remain in cis position, although it gives you a bicyclic product. So the hydrogen position remain the same as in the starting material. Okay, for rule number 4, when endo and exo products are possible, we usually prefer endo product because endo product is more stable. Okay, if we consider the reaction between 1,3-cyclopentadiene, with ethylene. Okay, a new 6-membered ring forms, and above the ring there is one atom bridge. Okay, this carbon is the one that form the bridge. Okay, thus the product is bicyclic, but the carbon atom shared by both rings are non-adjacent. They are non-adjacent carbon that is being shared by the carbon, by the ring, by the bridge. Okay, a bicyclic ring system in which the two rings share non-adjacent carbon atom is what we call as bridge ring system. So this is a bridge ring system because it forms like a bridge in between these two molecules. Okay, so what is the difference between a fused bicyclic system and a bridge bicyclic system? We know that in the Das-Alder reaction can give us a bicyclic system, whether it is a fused bicyclic system or a bridge bicyclic system. The same thing about these two systems is one bond is shared by two rings. And this CC bond here, it is shared by both rings, but the shared carbon are adjacent. In a bridge bicyclic system, the C are shared by two rings. However, this ring, the ring that are shared, is shared by two non-adjacent atoms. You see in the middle here, there is no connection between these two carbon, meaning they are not adjacent to each other. Okay, so this figure show how the mechanism of Das-Alder reaction. Okay, this is the plane of diene. You can imagine diene like a flat compound, and then there are dienophile, which is also flat, and the carbonyl on the dienophile is indo or tucked inside. Okay, and then what happens when these two reactant reacts? So a new bond will form. When a new bond will form, the numbers two step is the envelope flap moves up, and these are the one that form the bridge. And then after that, the hydrogen now moves to exo position, and the next substituent moves to endo position, meaning this will go up and this will go down. So what happens? You will get a product with hydrogen in exo position, and the ester part will go into endo position. Okay, let's take a look at this example. Draw the product formed in each cycloaddition. This is easy. Okay, what do? We just combine this bond, and then this move here, and then this bond will no longer, you will no longer have that bond, so you will get this compound. Okay, now question number 2, how do we get this? Is we draw a line here, then this will move, and then this no longer around, so what we will get is this compound. Okay, this is actually the same as. Okay, now what about this compound? What we have here, we draw these two lines, and then this will go here, remove these two bonds, so we will get this compound. And then for number 4, we can react these two, and then we will have a fused ring system, something like this. Okay, you can either draw it this way or this way. In this fused bicyclic system, this is not fused, this is a bridge bicyclic system. In a bridge bicyclic system, if you want to redraw, it is better to number the carbon atom. Okay, for retrosynthetic analysis of Das-Alder reaction, we know that retrosynthetic analysis meaning we start from the product, and then we want to identify the starting material. Okay, there are few steps that we can do. The first one is we need to locate the 6-membered ring that contains the C double bond C, and then we draw 3 arrows around the cyclohexane ring, beginning with the pi bond and 2 sigma bond, which then forming 3 pi bonds. And then we need to retain the stoichiometry of the substituent. So if we have a product that has cis substituent, then in the starting material, the substituent should also be in cis position. Okay, so this diagram show how we can conduct a retrosynthetic analysis on the Diels-Alder product. Okay, this is the Diels-Alder product. So now we know that it has 6-membered ring with the C double bond C. Okay, 6-membered ring. So this is the 6-membered ring. Then we have cis substituent. Okay, now we draw 3 arrows at the beginning of the pi bond. So the bond will move like this, here, and then the bond will move here, and then the bond will move here. So what do we get is a diene and dienophile. Please take note that this is cis. So your starting material should be cis. And then let's say if we have a Diels-Alder product, which is this one, we know that it has a bridge. Okay, so the new ring is the one listed in the one drawn in red color. So this is the new ring, and then draw the 3 arrows, and then what we get is this is the diene, and then this is the dienophile. Okay, that's the end of our learning unit 5. So take care and have fun learning.